Hi students, today we'll start a new unit and today we will introduce with the idea of transversals. There are lots of vocabulary terms in this lesson. The first is parallel lines, which many of you already are familiar with. These are lines that are in the same plane and they don't intersect. They do not intersect. They also have the same slope and are equidistant from each other. So if I was to draw a sketch of some parallel lines, this might look like parallel lines, but there's actually a symbol that we put on the lines to indicate that they're parallel. We never want to assume. And the symbol, it's kind of like a little arrow inside the lines, not at the ends. So that if you see that, that means the two lines are parallel. What it means that they have the same slope, it kind of means that they're angled in the same direction. So if these were on a coordinate grid, they would have the same slope. And equidistant means that that distance between the two lines, anywhere between the two lines, the perpendicular distance is going to be the same distance. The symbol for parallel lines kind of looks like a really tall 11. It's just two lines that look parallel that are vertical. Skew lines is probably a newer concept for you. They are lines. They also don't intersect like parallel lines, but they're not parallel lines. They actually are not in the same plane, but like I said, they're not parallel. So to demonstrate this, because it's kind of in a 3D space, it kind of helps if we draw a 3D figure and then I can show you skew lines on that 3D figure. So if we just want to draw a rectangular prism, and the way that I always do that is I draw two overlapping rectangles and then I just connect their corresponding vertices. So that kind of looks like a box. And I'll change my color so you can see this. So skew lines might be like this line here, and then maybe this line here. So what I want you to see, they're not going to intersect. Now if they were in the same plane and I hadn't drawn that green little box, it would look like they'd intersect, right? But they're not in the same plane, they're not parallel, and they will not intersect. So I can try to show you an example of this when we're in our live meeting, because it is a little bit hard to draw. Parallel planes are probably what you can imagine. They're planes that do not intersect. So we're talking about a lot of stuff that doesn't intersect, but there's more than just parallel lines. So if you look at this box that I drew in the diagram part, planes that don't intersect might be like this plane over here and this plane over here. They're parallel. Think of like the shelves in a bookcase. The shelves will never intersect themselves. They represent different planes that the books sit on. So let's try an example using some of these new terms. Here is a picture of a triangular prism, and that's important to know. It's just a normal triangular prism. So A says, what lines are parallel to line AB? Well, line AB is going to be right here, okay? Remember, lines continue. The other lines that are parallel to it are line DC here and line EF here. Okay, and then the way that we show that those are parallel is, remember, we want to put that little arrow somewhere on the line. So as long as I have one of those on each of these, then that means all three lines are parallel to each other. So the other lines that were parallel are line DC and line EF. Remember, when you're naming a line, you need 2 points from the line with that line and two arrows above it. B says, what are the other sets of parallel lines? Well, the bases, here are the bases. In a triangular prism, the bases are these triangles, and they should be oriented the same way, which means their corresponding sides should also be parallel. My picture is about to get real messy, guys. So For example, DA and CB, these are parallel, and I'm going to show that using two of the little arrows because I want to indicate that they're parallel, but they're not parallel to those other three lines we just talked about. So one set of parallel lines are lines DA and CB. Okay, I'm going to get another color. We have another pair that's DE and CF, and I'm going to show that they're parallel by using three little arrows. We just want a different number of arrows. So that was DE and FC. And then the last set of lines that are also parallel, we'll use purple, are EA and FB. You can barely see my letters anymore. And we're going to show that they're parallel by using four little arrows. So those were line EA and line FB. And remember, they keep going past my figure. All right, name a pair of skew lines. So there are lots of combinations here, but we want two lines that are in different planes that are not going to intersect. So let's see. Maybe we're talking about this line DE, okay? And then maybe we're talking about this line CB. So they're in completely different planes. They both come off of the two triangular bases, but the triangular bases themselves are parallel, which means these two lines which are in these planes will never intersect. They're skew, but they're not parallel themselves. Okay, so let's go ahead and write this combination just as an example, and there are others in the picture, but we'll write line DE and line CB. And then the last question says name a pair of parallel planes. Well, we kind of already talked about that, and those are those bases. Remember, when you name a base, or I'm sorry, not a base, a plane, you're just going to pick three letters from the plane that are non-collinear, and you put them together in any order. So that plane on the left, I could call it plane EDA, ADE, DEA, AED, all of those are fine. And the triangular base on the other end we could call FCB, or any other combination of those three letters. So now we're getting to the meat and potatoes of this lesson. We're talking about transversal, which is what this lesson's all about. A transversal is a line that intersects two or more lines in a plane at different points. So imagine if I had two lines in a plane, maybe something like this, and they might intersect eventually. They could be parallel, doesn't matter. But if I take a third line and I intersect both those lines, kind of like I'm just cutting through them, that line itself, that is the transversal. Okay? So in this picture below, the transversal would be this line Z right here. It cuts through lines X and Y. And what happens when we have transversals is that it separates our picture into 8 angles and different regions. So we're going to talk about those. So the 8 angles we see, I see 4 in this area and I see 4 in this area. Okay, but we also have some regions. So let's talk about some of those regions. All right, this part between the two lines, this is called the interior, which makes sense. Interior means inside. We use that word when we are talking about angles as well. And then the part that is above line X and below line Y, that is called the exterior. It's on the outside. So that's this area up here and this area down here. And I can shade in that area with, we'll do another color. maybe this cool blue color. So this blue part would be the exterior, and so is this other blue part. So it's really important that we understand the difference between interior and exterior because we're about to learn lots of vocabulary terms. So basically, if I pick any two of these 8 angles, there's some type of relationship. And so we need to learn, well, what are those kinds of angle pairs called? And then in the next lesson, we'll learn, what does that mean? What does that relationship look like? So these are the 5 types of angle pairs that are formed by transversals. The first are alternate interior angles. Alternate means on opposite sides. And we're talking on opposite sides of the transversal. And then they are also interior. So they're in the interior part. Oops, hold on. I wanted to use this. They're in the interior part of our picture, and they're on opposite sides of the transversal. So I'm going to swing back to our picture. We can take a look and find some examples of these. So remember in our picture, this is the interior part, right? So we're looking for angles in this interior part, and there's only 4 angles in this interior part, 2, 6, 3, and 7. And we're looking for ones that are on different sides of our transversal. So remember, here's our transversal. So we've got actually 2 pairs of alternate interior angles. Angle 6 and angle 3 are one pair. And then we have angle 2 and angle 7, that's another pair. So angles 6 and 3 and angles 2 and 7. So go ahead and add those to your examples. Alternate exterior angles are just like alternate interior angles, but now these angles are on the outside or the exterior part. They are also on opposite sides of the transversal. So if we look back at our picture, remember, here's our transversal. They need to be on different sides, and they need to be in these exterior portions. Okay, so we're talking about, and they need to belong to one angle from each of the lines X and Y. So, for example, we have 4 angles in this region. We've got 1, 5, 4, and 8. 5 and 4 are on different sides of the transversal, and they're both in the exterior region. So this is one pair of alternate exterior angles. Another pair of alternate exterior angles are angles 1 and angle 8. They're both on opposite sides of the transversal, different sides, and in the exterior region. So let's go ahead and add that as examples. So angles 5 and 4 and angles 1 and 8 were our examples. Same side interior angles are in the interior region, but this time they're on the same side of the transversal. So let's take a look at our picture. So remember, here's our transversal. The interior is this part. We still have those 4 angles, 2, 6, 3, and 7 on the interior, but this time we want to represent angles that are on the same side of the transversal. So we're talking about angle 2 and angle 3, excuse me, or angle 6 and angle 7. So let's add those as examples. So those same side interior angles were angles 2 and 3 and angles 6 and 7. Same side exterior angles are in the exterior region of the picture, and they are also on the same side of the transversal. So remember, we've got our transversal. The exterior is above and below. There are 2 exterior regions. The 4 angles in those regions are 1, 5, 4, and 8, but the ones that are on the same side of the transversal at different intersections are angles 1 and 4. They're both in the exterior on the same side of the transversal. And angles 5 and 8 are also on the same side of the transversal and in the exterior region. So those same side exterior angles were angles 1 and 4 and angles 5 and 8. So corresponding angles are a little bit different than the other 4 terms that we just talked about. They have nothing to do with interior exterior. They have to do with being in similar positions, but at different intersections. So let's take a look at our picture and see what that means. So the two intersections that we have, we've got these four angles up here and these four angles down here. If our angles are corresponding, they're in the same position. So for example, the angles in the upper left position of each intersection are angles 1 and 3. Okay? The angles in the upper right position are angles 5 and 7. The angles in the lower left position are angles 2 and angle 4. And the angles in the lower right position are angles 6 and angles 8. So we actually have 4 pairs of corresponding angles. So go ahead and add those examples of corresponding angles. They were angles 1 and 3, angles 5 and 7, angles 2 and 4, and angles 6 and 8. So now we're going to put it all together. We've got this crazy picture, and depending on how you look at it, any of those 4 lines could be a transversal because each line crosses through 2 other lines. So you might have to kind of rotate your head to kind of see it a little bit differently than the way we drew it in the last examples. Let's take a look at angles 1 and 5. 1 and 5. So the line that they both belong to is the transversal. So we're talking about transversal C, line C. That's this line right here. Well, if that's my transversal, then the lines that it intersects are A and B. So we're trying to figure out what type of angle pair 1 and 5 are. 1 is in the exterior, 5 is on the interior. So it's not going to be alternate interior, it's not going to be alternate exterior, it's not going to be same side interior or same side exterior. Whenever you have that, it's a very good chance that you've got corresponding angles. And the reason why these are corresponding is because they're both in the upper left position of this and this intersection. They're in the upper left position. Now let's take a look at the next one, angles 4 and angle 6. The line that they both touch, again, is that line C, which means that's the transversal. The 2 lines that line C intersects are lines A and B. So it's a very similar picture to the last example. So just ignore line D. Now 4 and 6, they're both in the interior part of those 2 lines. So there's some kind of interior, and because they're on different sides of this transversal, 4 is on the left, 6 is on the right, they are alternate interior angles, and I'm going to abbreviate, alternate interior angles. They're on the interior and they're on different sides of the transversal, so they're alternate. Angles 4 and 10, they both belong to this line A, so line A is going to be their transversal, and the lines that line A intersects are lines C and D. So we're completely ignoring line B and its angles. So if you kind of turn your head to the left or right, 4 and 10 are both in the exterior part of our picture, and they're on different sides of that transversal A, so these are alternate exterior angles. For angles 2 and 9, here's 2, here's 9. They both belong to line A again, so line A is their transversal. The lines that line A intersects are just like the last example, C and D, so ignore line B for this. Again, tilt your head right or left so you can see it kind of looking in the same orientation as our previous examples. Angles 2 and 9 are between lines C and D, which mean they are in the interior. And if you look at that transversal A that they belong to, they're both above line A, which means they're on the same side. So I'm just going to abbreviate this SS int for same side interior. All right, we got a few more. Let's look at angles 4 and 12. They both belong to line A, so line A is the transversal. And the lines that line A intersect are C and D. So again, we're going to ignore line B. But if you look at 4 and 12, 4 is on the exterior and 12 is on the interior. So remember, whenever you have that, there's a very good chance that you have corresponding angles. Okay, so the two intersections that we're looking at are this intersection, and they're both in the lower left quadrant of each of those intersections. Angles 3 and 9, they both belong to line A. Again, so line A is their transversal. Line A intersects C and D, so again, ignore line B. And angles 3 and 9 are between line C and D, so they're on the interior. You also notice that angles 3 and 9 are on different sides of that transversal A, which means these two angles are alternate interior. They're on different sides of the transversal. Now let's look at angles 2 and 7. They both belong to line C, which means C is your transversal. C crosses through A and B, so we can kind of ignore line D and its angles for now. 2 and 7 are both in the exterior region, which means they're exterior angles, and if you notice, they're on separate sides of that transversal C. 2 is to the right, 7 is to the left. So we're going to say they're on different sides of the transversal, so they're alternate. And since they're in the exterior region, they're alternate exterior angles. Angles 3 and 12 are here and here. They both belong to line A, so A is their transversal. A crosses through C and D, so we'll ignore line B. Angles 3 and 12 are both between line C and D, so that means they're in the interior. And if you notice that they're both on the same side of that transversal A, they're both below it, we're going to say that they're same side interior, SS int, same side interior. The last example are angles 1 and 7. They both belong to line C, which means C is the transversal. C intersects lines A and B, so we'll ignore line D. Angles 1 and 7 are both on the exterior portion, and if you notice, angles 1 and 7 are both to the left of that transversal C, which means they're on the same side and they're in the exterior. So these are same side exterior angles. So it's just going to take lots of practice looking at these, tilting your head, identifying what's your transversal, where's my interior, where's my exterior, are my angles on the same side of my transversal or different sides, and are they in the same position? Could they be corresponding? So we'll practice this and we'll talk more about it in class. Bring your questions. Good job.